here's our first trig equation that's quadratic in form. That just means that the highest power of a trig function that we have is the second power, so that we're squaring the sine function. Okay. So I want to solve this, same directions as we've been using. I want to start by telling you what I'm not going to do. It's very tempting to divide both sides by sine x. However, I can only divide by something if it's not 0. I don't know if sine x is 0 or not. And in fact, I can sort of see if sine x was 0, that would actually give me a solution to this equation, because that would make both the left and the right-hand side equal to 0. So you can't divide by a variable quantity unless you know that variable quantity isn't 0. If you do, you're going to lose some solutions. Okay. So what I'm going to do instead is I'm going to move everything over to the left-hand side and set it equal to 0. So I'll have 4 sine squared x minus 3 sine x equals 0. Now I can factor. So same thing I do when I've got just x's to higher powers than just the first power. I'm going to try to factor things. Okay. Looks like I can factor out a sine x. So I get sine x times 4 sine x minus 3 equals 0. Now, it's super important that it's equal to 0 before I factor, because 0 is the only number we have where we know if two things multiply to give us 0, one of those things is 0. That doesn't work for any other number. Two things multiply to give me 1, they could be 2 and 1/2. Neither of those is 1, but yet their product is 1. But with 0, if two things multiply to give me 0, one of them is 0. So now I can set each factor individually equal to 0. So sine of x equals 0. Those are the solutions that I would have lost if I had made the mistake of dividing through by sine at the beginning. Or 4 sine x minus 3 is equal to 0. Okay, so let's solve this first one. If sine is equal to 0, I know we're really just looking at some quadrantal angles. So I'm going to draw myself my unit circle. Sine is 0 when the capital Y value is 0. So that would be here or here. In this interval, there are two angles that we would get, 0 and pi. Now, of course, this point corresponds to 2 pi as well, but that's not in this interval. And the reason we don't include it is because it's coterminal with 0. So when I move on to get all solutions, I'm going to take these solutions and I'm going to add a multiple of 2 pi to them. That's going to give me 2 pi if I take 0 plus 2 pi. Okay, so now if I'm looking at this one, if I isolate the sign, that's going to mean that sine of x is equal to 3/4. Okay, so let's think that's a positive number. So I'm going to have one solution in quadrant 1, and the other quadrant where sine is positive would be quadrant 2. So I'm looking for two solutions here, one in quadrant 1, one in quadrant 2. 3/4, that's not going to show up in a 30, 60, 90 or a 45, 45, 90 triangle. And this x is just an acute angle. So here, this x is just arcsine of 3/4. Here, that's going to be my reference angle. Okay, that's the acute angle that has the right sign. So here, x is pi minus alpha, which is pi minus arcsine of 3/4. So my solutions between 0 and 2 pi would be 0 pi arcsine of 3/4 and pi minus arcsine of 3/4. Excellent. And then if I want to find all solutions, I'm going to just take each of these and add a multiple of 2 pi to them. I can, if I want, be clever and consolidate these. Notice that 0 and pi are exactly pi apart. When we looked at the unit circle, they were separated by half of a rotation. So essentially, if I add a multiple of 2 pi to this, I'm going to get even multiples of pi. If I add a multiple of 2 pi to this, I'm going to get odd multiples of pi. I can sort of consolidate and just say I'm going to get all multiples of pi. Something coterminal with 0 would be an even multiple. Something coterminal with pi would be an odd multiple. I'm going to go ahead and do that just because that's a little bit more efficient. I would be fine with you telling me you're getting 0 plus 2 pi n and pi plus 2 pi n. And again, once I've listed all my solutions, I'll state that n is an integer. Okay. So then we've got arcsine of 3/4 plus 2 pi n and pi minus arcsine of 3/4 plus 2 pi n, and in all of these, n is an integer. Okay, excellent. There's really no nice way to consolidate these. We can only sort of consolidate our answers if they happen to be separated by pi, and then we can write all of them together as we did here.